Hi, let's get started with preliminary section 1, sets and geometry. So what I've got here in front of me is a printout of the guided notes, which you'll find on D2L. And so in this section, we're going to be talking about sets and geometry. So what is a set? A set is a collection of objects. Could be a collection of numbers, collection of points, and every object in the set is called an element. And one set you might have heard of is the set of natural numbers. Natural numbers are also called counting numbers. They start at 1, so the numbers 1, 2, 3, 4. This is an ellipse. That means and so on and so on. It goes off into infinity. So that would be set N. The name of the set is an uppercase letter, and set elements are surrounded by curly brackets. So here I'm going to have the set G. Let's say these are all the grades that you can earn in this class. Well, you can earn an A, or you can earn a B, or you can earn a C, or you can earn a D, or you can earn an F, or maybe we'll give you an incomplete also. So this set has 1, 2, 3, 4, 5, 6 elements. And an element is either in the set or it's not. There's no concept of the first element or the last element. We could have rewritten set G as B, A, C, D, I, and F. All right, so elements are either in a set or they're not. They're either members of a set or they're not. So the natural numbers are the counting numbers 1, 2, 3, 4, 5, but there are other kinds of numbers that we'll be using. And for instance, we have decimal numbers and we have fractions. And numbers can be written as a decimal or a fraction. And so in order to find the decimal form of these numbers, you'll use your calculator. So what's the decimal form of 3/4? So you put in your calculator 3 divided by 4, and you'll see the decimal form of 3/4 is a terminating decimal 0.75. If you put 3/11, 3 divided by 11 in your calculator, you're going to see that there's, we could have put a 0 here. There's no whole number, and then there's 2, 7, 2, 7, 2, 7, and that repeats. And since the 2 and the 7 repeat, we could put the repetition bar or the repeat bar over the 2 and the 7. All right, how about the square root of 2? Square root of 2. Now this does not repeat, and this does not terminate. Square root of 2 is 1.414, and since the number after the 4 is less than 5, we would drop that. We would just make that 414 if we wanted to go to 3 decimal places. And then pi, make sure you can find the pi button on your calculator. Again, this does not terminate or repeat. That would be 3.14159, and since the number after this 5 is 5 or greater, if we wanted to round that, we would say that's approximately 3.1416. So here I have a fraction and its decimal equivalent, a fraction and its decimal equivalent, a radical and its decimal equivalent. And then we have our real number, pi. It's an irrational number, 3.1416. So let's continue to talk about sets of numbers. We've seen natural numbers, and we've seen decimals, and we've seen fractions. Some sets are infinite, which means there's a definite number of elements in the set. The number of elements in the set can be counted. And the symbol N with the curly bracket and the name of the set to represent the number of elements in the set. So here, if I have the set 1, 2, 3, the number of elements in that set would be 3. So if I wanted the number of my set A, B, C, D, F, or I, 1, 2, 3, 4, 5, 6, the number of elements in that set would be 6. So we have named sets, uppercase letters. We can find the number of items that are in a set if it's a finite set. But then there are also sets that are infinite. These have an uncountable number of elements in them. They go on forever and ever, and it could be into positives or it could be go on and on into the negatives. So there are too many elements to count in an infinite set. So when every element of one set belongs to another set, the first set is called a subset. So in this particular example, if A was 1, 2, and 3, A would be considered a subset of our natural elements, and we would write that A is a subset. A is a subset of the natural elements. All right, so how about if I had my passing grades? To move on to the next class, you have to get an A, a B, or a C. We would say that set P is a subset of all the grades I might get in my class. So that's sets, infinite and finite, and how to find the number of elements in a set and curly brackets. Now let's talk about sets of points. A point is a location. It does not have a size, but a point name is an uppercase letter. So here's the point K. Try to make your points kind of small, but there's a point J. There is no concept that J is bigger than K. All right, a point does not have a size. It just has a location. But we're going to represent our points with uppercase letters. And so if many points appear together, they will create a path. So here's a path that looks like it's going in a straight line. Here's a path that looks like it's going in a curved line. Here's a path of points going in a circular pattern. And here's a path of points, they appear to be scattered. So you can think of this path as stepping stones going from one to another. In other words, there's airspace between the points. This is not a path. Okay, scattered is not a path. But when we talk about 3 points on a straight path, we generally mean that one of the points is between the other 2 points. That does not mean that it's halfway. So if I have the point K and I have the point W, my first name is Catherine, my last name is Worley, and here I have a point T. If this is on a path, a straight path, we would say that T is between K and W. The point T is between. It does not mean it's halfway. It does not mean that it's the midpoint. It does not mean that it's the midpoint. It just means that it's in between on a straight path. And betweenness is going to be an important concept in geometry, points that are between. So let's go back and continue to look at more information about our sets of points. A line is formed when an infinite number of points follow a straight path. And a characteristic of a line is that between any 2 points, there is always another point, and there's an infinite number of points, so it's really dense. So the line is considered continuous. So here I have the point K, and here I have the point W, but there's a point right next to it, and a point right next to it, and a point right next to it. And this would, and in fact, there could be points in between all of those points as well. So that's why this line would be considered continuous. And we'll put the arrows on there to get used to some notation for sets and for lines. And eventually we'll use a ruler to find the length of a line. The length of a length of a line segment. A line segment has endpoints, but a line and array do not have lengths. They go on, their points go on forever and ever. That's why we would put arrows at the end of our lines. Okay, so if we, the paths created by the points are known as discontinuous. This is discontinuous. This is continuous. This is discontinuous. That would be continuous. So a line segment has two endpoints. Here's the point A and the point B. A ray has one endpoint. So that goes from point A through point B and on to infinity. And then a line has no endpoints. There's going through point A and through point